Hello, everyone, and welcome to an exciting session of Teens in Action Forum. My name is Chi, and I'll be your host and facilitator for today's event. I'm super excited to be here with all of you as we explore some exciting topics in AI, technology, and innovation. Today's session will be on sports and AI, the winning formula. For those of you who may be new to us, Teens in AI is an award-winning social impact initiative that was launched at the United Nations AI for Good Summer in 2018. Our mission is to empower the next generation of AI leaders and innovators. And over the years, we've reached more than 20,500 young people in over 252 cities across 97 countries worldwide. Such an amazing feat we've done. Today's session is in partnership with SAGE, an organization that is committed to inspiring a new era of AI leadership, and together we are paving the way for more young people to make a difference in AI. Before we get started in today's event, we would like to let you know that it would be great for you to stay till the end because there is a lot more that you'll be learning. We'll also be letting you know about our latest courses and our upcoming events. If you're passionate about AI and would want to take your skills to the next level, please stay tuned and don't miss it. All the details will definitely be at the end of this session. So moving on to today's session, we're going to be letting you know more about sports and Farhan's journey into AI. We'll also be learning about artificial intelligence and how data science, they are both transforming sports games. And of course, we'll give you the opportunity to share your thoughts, give us your questions, and also get feedbacks as well. And just before we dive in, we'd like to let you know how things will go out today. First, keep your mind open and be curious. Don't hesitate to share your ideas with us. This is a no judgment zone as well. Respect everyone's opinions and let's keep our discussions positive and constructive. And of course, we'll make sure that we end on time. Okay, for today's session, I'm excited to introduce our speaker, Farhan Tinwala. He's a sports scientist and an engineer who has ended up in the world of data science, and he works with the England men's cricket team. He has worked with elite sports such as athletics and cycling to deliver innovations and technology projects and push a lot of things forward. It's with so much joy and with pleasure that I welcome today for our event Farhan Tinwala. Ladies and gentlemen, please give him a warm welcome. Thank you so much, Farhan. Over to you.
Thank you, Chi. Appreciate that. Just share my screen. All right, let's get into it. Thank you, Chi, for that introduction. I just want to say thank you to Teens in AI for organizing this session and this workshop, and also thanks to Sage, who is a valuable partner with the 100 and the ECB. I was told that through this partnership last year, 4 teens had the opportunity to participate in all technology that's used in cricket and attend a handful of 100 matches, which was a really cool experience. So thank you all, and looking to get into it. Just wanted to share a little bit about myself and my journey so far. I haven't had a traditional journey into sports science or data science. I began my journey as a mechatronics engineer. I studied engineering in university, which I really enjoyed. And then I ended up in a job which I didn't enjoy. I worked in manufacturing for a little bit. Turned out I wasn't suited for the 9 to 5, the working for shareholders and other people's profits. That didn't drive me or have any motivation. But what I realized my passion is sport. I love sport. I grew up playing sport. And decided to do a PhD in sports science and sprinting performance. So I worked with a lot of athletes, elite sprinters, to help them improve their sporting performance, to get them faster. And that led me to a job at the New Zealand Olympic team, where I helped work with elite cyclists, sprinters, rowers, and so forth, helping them with innovation, technology, data science, analysis, which was really, really cool. And about 3 years ago, I moved to the United Kingdom and ended up at England Cricket working as a data scientist. I just wanted to share this because, like I said, it hasn't been a traditional path for me to end up here. And that doesn't mean that you have to also follow my path, but there are many ways to get here. I know that now the universities offer specific courses in data science in sports analysis, especially here in the UK, but also around the world. There are loads of opportunities to do what I do and study that directly, which is really cool, which was not available 10, 15 years ago. So I'm really grateful, and hopefully you guys get the opportunity to if you choose to pursue those opportunities. So yeah, so that's me so far. I thought before we get into um, the world of data science in sport and cricket, I'll talk a little bit about what analysis is in sport. And the quote that I like to go by is, "We take observations from sport and turn it into feedback, and we use that feedback to improve our sport." By observations, I mean anything we can measure. We take those measurements, we do calculations on them, and then we present them back to whoever's asking the question to then go improve the performance. And that's the underlying principle. Why we do it is because we want to improve the game. We care so much about our sport. We care about our players. We care about our coaches. We want to improve. And that's why we're there. We're there to support them. So that's performance analysis in sport in a very, very simple but high level nutshell. The way it works is, with, like I said, observation, feedback, and improvement. And I'll talk through a few of those in that order. So the first one is observations. How do we observe? What do we use to observe? And the most common thing in performance analysis is a video camera. It's been a staple for many decades now, a video camera. We record our matches, we record events, we record training, and we use that as feedback. So that's one of the basic tools we use, and it's still to the day, probably 70% of our work is in video. There's so many different sports that still use various tools for video to analyze and report. The other way is, you guys would have seen it, is through your TV. You see and watch sport. That's how you consume sport as a form of entertainment. But we also, as analysts, use that feed to help us. Those are the matches, those game events we can use to replay, reflect, and learn as a team, as individuals, as players, as coaches, which is really, really cool. The next thing I want to share is more cricket specific. Some of you guys may have seen this or may not have, is a scorecard. That is our way of generating data and capturing data, using scorecard to capture information about a match or an event. A lot of other sports would use this. Rugby or football will capture events like a pass or a tackle. We call this notational analysis, where you capture events, you objectify them, and put them in numbers or a format that you can digest later. So that's another thing that we use to observe and measure. Again, sticking to the cricket example, we have a way of tracking balls in real time, which is really cool, with a company called Hawkeye and a few other companies around the world that track the ball. It's also available in tennis. That's a really, really big way for us to capture what is happening on the field in real time. So those are some of the other elements of observations that we can use. The last one is player specific. And these are not exclusive. There's a whole lot of other technologies and tools out there that we can use to observe and measure information. But this here is a GPS sensor that sits on the back of a player. A lot of sports use this, right? Say rugby, football, and netball, all sorts will use these sensors to capture physical information about an athlete, what they do during a game, but also during training sessions, their load, their workload, the intensity, so forth, which is, again, adds to the pool of information that we start to collect, and then we just keep growing and we keep growing that information. Performance analysis does work a little bit hand in hand with technology. We are not reliant on it, but we use it to innovate and grow with the technology. So as evolutions in technology take place, the analysis or performance analysis also evolves and takes place. And that's great, because we get to ride that wave and we get to experience all the benefits that come with it. The challenging bit, which is the next bit, is when this grows and grows and grows, you have all that information, which is data. You've got so much data. What do you do with it now? And this is a big challenge of data in the real world. Now, I've used this example as this is the matrix, or all you see is numbers, ones, zeros. Some of you may be too young to get this reference, but essentially, as data scientists, this is what we see. We see numbers just going up and down. Now, that's has his own opportunities, but also challenges. When you're collecting data from so many different sources, we have to clean it, we have to store it, we have to figure out how to filter it. So all these techniques also play a crucial role in my jobs particularly. And if any data scientist tells you that they don't do this, they're lying to you, because a lot of our jobs is actually massaging data, cleaning data, figuring out errors. And the reason for this is the way we capture information is humans. And humans are prone to errors. The way we design instruments also has measurement bias, so we have to account for that. There's always going to be information that needs to be adjusted and accounted for. So these are the actual challenges that we face day to day when dealing with large sets of data from different sources, combining and combing through. So we've got through observations, we've collected data. What's next? Feedback. All right. So we've gone through, we've collected data, we've processed it, we've applied our algorithms, our models, our calculations, whatever we want. How we answer the question that was presented to us. What is it that we need to do? How do we get that information back to the coach, the player? Is it through graphs? Is it through numbers? And feedback is probably the most important part of our role as performance analysts and actually data scientists. Because if there's no point doing all the really cool calculations with the data, with collecting the data, if you're not going to be able to present it back to the coach or the player that asked for it in the first place. So understanding what they want, how they consume the information, what works for them, and it could be very little. It could be a font or a color, but that makes the difference. Is it a graph or is it a table? These are some of the things we have to take into consideration when we present information back to our users or stakeholders. So just wanted to take you through a little bit of that journey around what is performance analysis and what it looks like in sport. And the next bit, which is a cool bit, I think, is the AI stuff, the machine learning, the algorithms that we use to help us answer some really complex questions. Before I get too into that, I wanted to share this metaphor, and forgive me for the poor metaphor, but I still think it's relevant here. AI is a tool, it's not a compass. And that I wanted to drive home here is we always use AI to supplement our questions. We don't use it to determine new questions, if that makes sense. It's always about what you're trying to achieve rather than what is it you're trying to achieve it with. So that's what I wanted to keep in mind when we go through the next bits of this presentation, is that there's always AI, anything that you use is a new tool that we can use. It's a really powerful tool that was not available to us a few years ago, but it's growing, it's changing, but it's still just a tool. It's at the end of the day, it still comes down to how good is the question that you're trying to answer, the impact that you're going to have at the end of the day with the players, with the coaches, with the team that you're working with. So that's one thing, again, like I said, I wanted to drive home. So let's get into it. Let's get into the stuff that we use in cricket, in other sports, specific AI models. One model that you might have heard of or have come across is expected models. It's a very simple, I guess, concept, but it has a lot of power, a lot of importance. Essentially, what it is an estimation of a probability of an outcome. So, for example, in football, is how many goals does your team expect to score in a particular match or in a particular series, or a World Cup, for example. In cricket, for us, what is a success? What is the outcome of a run scored or a wicket? And same in basketball, it could be wins, it could be points, the likelihood of a 3-pointer versus not. So basically, it's just a probability statistic that can be grown and shrunk down to complexity that you want to. The graph here on the right just shows you actual versus expected. And the way we use it is what the value that we get out is the way we use it. Context for this is quite important because what happens with expected models or expected runs and wickets or expected goals is you can add and remove context as needed. So we can adjust it for the quality of the opposition. So for example, we know that in the next match, we expect to score 3 goals against this team. But now actually this team that we're playing is really highly rated or has really good players, or we're playing them at home, so the home advantage. How do we factor those? So having a model that you can dial up and down the level of context or inputs in this case is quite common. And this is used in a lot of sports. And rugby use it, like I said, football use it. Well, we at England Cricket have our own models. A lot of cricket clubs and cricket boards around the world have their own models that they dial up and dial out. The graph, going back to the graph again, I wanted to share a little bit about what that means. So if you had the blue line and you've got actual goals above and below that blue line, we can find out the area under the curve or above the curve, and that we can determine as an objective quality. So did you perform above what was expected or below? And that we can start to do really cool stuff by aggregating across time, comparing different players and teams in different circumstances, which, like I said, just opens up many doors and possibilities if we wanted to. And that's the power of an expected model. And it is, again, it's a system that's been around for a little while, but has grown through the various advancements in machine learning, through random forest models, XGBoost models, and so forth. Lastly, it's used in multiple areas. Like I said, because it's a baseline model, we can then scale it up and down to help us in selection, to understand how we strategize and configure our tactics of particular opponents or matchups and go so forth. The next thing that I want to share was our win predictor model. Again, a lot of sports have their own version of win predictors. Essentially, it's a saying what was the likelihood of me winning the next match or me winning the next game or the series or World Cup. In a nutshell, that's in its simplest form is that we can then move it into a more real-time probability estimation. So this example here is a cricket specific one. Through the x-axis is time or overs. Throughout a match, you can see the win probability changing between the two teams. You can then use this to understand how the match changed momentum and pressure, who was under pressure and how. So that is another model that we would use quite often to help us answer some of these questions. Both those models, like I said, this one and the expected is trained on historical data, which we're really fortunate to have in cricket. Cricket is a very old sport, has probably got 100 years of match data that we can feed into these models. Obviously, the game changes and evolves, so we don't use all 100 years. But all these models are based on heavy historical data. And again, that comes with its own challenges, like I mentioned, around the data, around data cleaning, standardization, filtering, and so forth. As I mentioned, momentum and pressure, this helps us understand how teams and players behave when they're behind the game. So for example, if your win percentage was 5, you're behind the game, and did you help your team get to a better win percentage, or did they end up losing, and so forth. So we can start to look at how players perform under pressure, teams perform under pressure, or teams thrive under advantage or disadvantage. These are some of the things that we can use. So these two models that I wanted to share with you are essentially the bread and butter of a lot of sports. They will use these to help them answer their questions that come to them. I'll share with you a couple of more examples. We also have a simulator that we will use. A match simulator helps us allow simulating to help us plan for scenarios. We can then filter between playing 11, who the opposition is, our match conditions. We can then using those two models that I shared, we can simulate whether or not we would win, or if we lose, or if we're going to perform or below or above average, for example. So that's another tool. And a lot of sports will use this. Football will use this to help. Rugby will use this to help understand their scenarios. Their set pieces is quite common to understand the efficiency of a set piece. They would simulate a set piece to see if it's going to result in a goal or point scored. The other thing that we use in cricket especially is a par score. Cricket is an interesting game where you have to score more runs than your opposition. But you as the team batting first, you have to know what to score essentially. What is the right amount that you need to win the game comfortably? Again, we have a series of models that we use based on a whole lot of historical data, taking into conditions, which is another big factor in cricket, less so in other sports. What the grass is doing, what the ground is doing, what the ball is doing in the air. So you have to take all those things into consideration. So we input all that information into our models to help us determine actually if you're playing in this venue against this team, you need to score these many runs to give yourself a solid chance of winning the game. And then we can then use that to feed into the simulator to simulate scenarios and build a really comprehensive picture of a game before you go into the game. So the players and the captains know their strategy and they know their tactics when it comes to the game. The last thing I want to share is a lot of sports again have a comprehensive way of understanding their pathway. Who are their next best players coming through through talent identification and development, academies, so forth. One of the most important things and models people use is feature selection. You feed in a whole lot of factors that you measure from a young age, and then you can determine based on that what are the most important or the most deterministic of success at an international or at that level, the high level, elite level, which is another good thing. And through those through that process, you can start to figure out what is actually important. For us, I know in cricket, it's not so much just scoring runs at a young age, or it's actually about how motivated you are as an individual at a young age, how you tackle challenges and how you overcome adversity. Some of these things we would not have known if we hadn't gone through a feature selection method to understand. And then we can then look at how we identify those traits in individuals coming up through the system and bring them up. Yeah. The last thing I want to share with you all is a method that I think we as performance analysts especially apply in our day-to-day job, and it's called the performance backwards approach. And I've alluded to it in this presentation, is we always start with the question first. As I said, AI and any other tools we use are actually just tools, but it all starts with the question. And I wanted to take you through an example of how we would work in a day-to-day environment as a cricket performance analyst. So we would get a question, and this could become a question, would come from a coach, a player, a selector, anyone. And for this example, let's go with how fast do our bowlers need to bowl to be successful? Now, if you're not familiar with cricket, don't worry. It's just an example, a question that is rooted in a clear direction of impact on the game. We want to be successful, and we know that our bowlers need to bowl faster, or do they need to bowl faster? So that's the question that's come up. Now we can go through that approach that I had first shared about observations. So what do we need to first observe here if we break that question down? Well, I need to figure out what is fast. So speed sounds like a good start. That's my input. I can input that. And it looks like success is my output measure. So those are the things I need. I may need more information, but let's start with that. The data, do we have the data? Do we need to go out and collect more information? And then applying those same principles around data cleaning, filtering, and do you even have enough of it? Then we can look at what tools there are, what is appropriate, what are the calculations I need to do. Once I've got the data, do I need to look at linear regression, decision trees? What are the AI models and machine learning models that I can apply to this to get the answer that I'm looking for? And again, it's rooted in the question first, and then we look at which tools are available to help us answer that question. A lot of the times, it's the simple is the best approach. So to answer that question, it might be that you just apply a simple statistic or a math equation. You don't need to go into complex AI models. And again, if your audience that you're presenting to does not have the ability to understand some of those complex methods, then it's maybe not appropriate to apply. So this is at this stage is where you do a bit of filtering, you do a bit of planning around what is appropriate, who is the information that needs to go to. And that's the final step of this approach. Is you've calculated what you wanted, you figured out you need to bowl really fast, but I need to send this information back to whoever asked it in the first place. Now, is it we create a report or a graph? Is it just a conversation with the people? You sit down with the coach or the players, and like, this is what we need to do. So that is the next step. How do we actually share that information back up so that it answers the question, but then fundamentally helps us win and succeed at that level? So that's an approach that I really want you to understand and take from this talk. Finally, I want to give you a little task, a little bit of homework for you guys to go away and conduct yourselves. I want you to pick a sport, any sport. It doesn't matter if it's a sport you play or you don't play it, or if you're just interested in it. It could be bobsleigh, speed skating, or downhill cheese rolling, for example. You could be anything that you want. It could be esports. Just pick a sport and try and ask a question similar to the question that we had. Just come up with a question. Think of yourself as a player or coach in that sport. What is it that you want to ask? What is the strategy? What is the tactics question? What are the, what is the thing that you want? Just there's no right or wrong answers for this task. Go all out. Start with a question, then take it through that approach. Have you got what you need? The observations, the data. What tools do you need once you've got that information? And then when you've learned that stuff, you've answered that question, how do you take it back to whoever needs to know? So this is what I want you to do. I want you to go through this example in your own time and go through it and see what comes out. And I'm curious to know what you guys come up with. So that's very much my talk. So I'll hand it back over to Chi for the next bit. Thank you.
Oh, great. Thank you so much, Farhan. That was an amazing session, and I'm very sure that everyone on the call has really enjoyed themselves and they've also learned something new. Thank you so much for doing this. We appreciate you.
Thank you.
All right, so now it's time for us to go into the Q&A session. So if you have any questions for Farhan, we'd like you to drop them in the Q&A box on your screen. Just do that for us so we can get started with the questions. I'm sure we all have questions to ask him. I can see some questions already here in the comment section, so we'll start from them now. Okay, so I have a first question waiting for you. So the question says, what is the most challenging aspect of your job?
Oh, good question. Good question. I think I sort of alluded to it earlier. The biggest challenge of my role in particular is the data, cleaning the data. It is a big part of my role, which when you first sign up for it, you don't realize how big it was. But it is a step you need to take to do the cool stuff. To do the AI, do the stuff. You have to go through that to do that stuff. And sometimes you can also use AI to help you there. So that is a big challenge, but as any data scientist, you have to go through do all the engineering, the data massaging, the cleaning and filtering that comes with it.
Okay, all right. So the very next question says, what would you recommend to others wanting to build a career around AI and data? What would you recommend to others wanting to build a career around AI and data?
Oh, what would I recommend? I think if you're genuinely passionate and interested in AI or data science, study it. I think that would be the first thing. There are so many different courses, and you don't have to. When I say study, you don't have to do a university degree. You can choose to do a whole lot of courses that are available online for free, even through smaller courses. So I just say just search what's available. There are so many different local communities that also offer now courses in AI or anything, or even specific to the industry that you might be interested in. If it's health, for example, or sports, you could choose that pathway. So that would be my recommendation. Just go and find and study it.
All right, thank you. So moving on to the very next question. What was harder, gaining the tech skills or gaining the sporting knowledge for your current role?
Oh, what was harder? I think there is two parts to that question, right? The tech skills, I think personally, and this is obviously will be different for different individuals. It has been easier, so the tech has been easier than the sporting knowledge. The sporting knowledge is by levels. So when I came into cricket, for example, I had a very basic understanding as a fan, as someone who might have played every now and then. But to take it to a level that players, coaches understand was hard, and I'm still on that journey. I'm still learning and I'm still growing. Same with my tech skills. I'm still learning as I go. Like I said earlier, I'm not a trained data scientist. I am self-taught, but it is always a journey. You're always learning. And like yeah, the the cricket knowledge has been the hardest one.
Okay. We'll just add a question. I think Chi went offline. So next question is from Joseph again. Is it cheating if a team uses AI to decode the opponent's strategy?
Yeah, very good question. Very good question. Um, So sports are each sport is quite unique, obviously, and each sport has got its own rules and regulations of the game, for example. And we have to grapple with the fact that when we have a innovation or technological innovation in the sport, how do we best use it to our advantage? But is it still staying within the spirits of the sport? And that's always a dilemma that you'll have to go about. And we call it actually technological doping. Some people call it that, and that's that's a pretty serious thing. But at the same time, innovation needs us to push the envelope further. So using AI to decode another team's strategy is just using a new tool to stuff you probably already do before. We've already tried in football, for example, you'll review footage of your opponent leading up to their match anyways. But now you just are using a new tool to expedite that process. Some may argue that that is crossing the line of the spirit of the game. But one of the things I want you guys to think about and contemplate is how far do you push that line? Um, and was it in the spirit of the sport? Because it's not a black and white answer, unfortunately. And there is a bit of gray area, and it comes down to debate and open conversation around what do we want to achieve out of sport? How much we put how much importance do we put on innovation in sport? Um, and also how much importance do we put about equity and equality within sport? So sorry, I've got a winded answer, but it's unfortunately not an easy answer.
Okay, so I can see another question from Anika. She's asking, you mentioned biases in the collected data like home ground advantage. She would like to know if you could elaborate on this and correction methods for that as well.
Yeah, sure. So I think there's a couple of parts to that question. So the first part is in terms of biases, there's measurement bias or error essentially in information that we collect. And that's what I was trying to allude to, that information may have errors or bias that you have to correct for later. For example, if you use a video, if you're collecting video from a different angle versus you collect a video from another angle. That's a technical question. But then in terms of bias in home advantage or away advantage, calculating those again is not easy, but you can do that. You can look at teams' records at their home grounds versus neutral grounds. You can feed that information into a machine learning model to help understand probabilities of or weightings of those advantages, biases, and you can go through for each team. You have to apply that with a sports lens as well, because sometimes you have to make sure what it puts out is still relevant. Is this team actually really good at home? Actually, well, we know they play like this all the time, regardless of where they are. So maybe not. So there's a bit of sort of domain expertise that has to sit over the top of those calculated biases or advantages. Let's call them that.
Okay. More questions are still coming in. So I have this. For you, what is the most complicated sport to combine with AI?
Most complicated sport. Oh, I don't know. I haven't actually experienced that many sports. But from the ones that I've worked with, I would say cricket, actually. And the reason for that is, well, sports in general are human-based. I think I talked to it, but as humans, we are prone to our own biases, our own errors, and our own opinions and contexts. When humans play other humans, that compounds the effect of errors and biases that we have. AI works really well when you have constrained information, collected data that's clean, that's manageable. You can work around some of that, but in most cases, that works really well. So for example, a sport like cycling or rowing, where it's time-based, it's constrained, it's heavily constrained, it's not complex relative to someone like cricket, where it's open-ended. You've got so many different factors. You've got the weather at play, players' feelings, confidence levels, pressure, momentum, all these aspects that make it very complex. So it's what excites me, to be honest, because it's so complicated. That's why. So I think if I had to pick a sport, it would be cricket. That's probably one of the most complicated AI sports to apply AI in sport. That makes sense.
Okay. All right. I have another question, and this is asking, how do you think the world of data science will change with the development of AI?
Well, I think and again, this is just my opinion. As AI tools grow, as us as data scientists, it's our job or our responsibility to be shepherds of it in our own industry. So we will. One part of my role is I also keep looking on the horizon as what's coming up in terms of AI tools, any large language models that are coming up that could be applicable or not. And so that's just a part of the job. You just have to grow with the tools that are available to you. I know 20 years ago or 15 years ago, we still use the same methods we do now. They're just faster. We have more computational power. We still apply statistical inferences to do, calculate the percentage of Usain Bolt winning the 100-meter sprint. We just now have more complex tools. So I think it's a responsibility as data scientists to still keep an eye out, to shepherd in new advancements in technology and adapt them to what you need to impact your game and your sport.
Okay, this must have really been an exciting session because more questions are still here. I just saw one interesting one. Would you let AI pick your cricket team over your coach? Interesting.
Yeah, good question. Good question. Short answer is no. Not in cricket. No, no. And again, the reason I say is that we work in a very different way than a lot of industries would in using AI. And what I mean by that is we're not driven by AI or data. We are data supported or something along those lines. We use the information from the AI, like those expected models or the win percentage models or whatever the information is, alongside a whole bunch of other things that we got to consider before you make a decision. So when selecting a team, there is a lot of thing that goes into in front of a selector or a coach and whoever the decision makers are, not just here's the best 11, go play, based on this model. Because like I said, cricket is a very complex sport. There's a whole lot of other things that we can't measure yet. Maybe someday we'll be able to measure and we'll be able to develop those AI models. But at this moment in time, we are sort of supplemented by AI, supplemented by data to make decisions.
Okay. Someone would like to know the strangest data request you've ever gotten. Strangest data request ever.
Well, that's a
Yes.
good one. Strangest data request. Oh, I have to think about that one. We had a bowler that came up a while ago and asked about. Oh, it's not really strange. I'll come back to that one. I'll come back. Let me have a think of that. I'll have a think of that, and then we'll
Okay.
come back to it. Yeah.
All right. I have another question. Is there another sport you like to work in and apply your skills?
Another sport I'd like to work in.
Yeah.
Yeah, maybe. Yeah. I mean, again, I'm just a fan of all sports. That's one of the reasons I joined this industry. I'm inherently very competitive, as a lot of humans are. So and also I'm from New Zealand, so I grew up playing rugby, and watching rugby. So rugby is another sport that I'm really interested in, and that would be cool to be part of. We had done a little bit of work when I was in New Zealand, with the sevens, rugby sevens team. So that was really cool. They do some really cool stuff. So yeah, it's another fascinating, complex sport, which is also doing a lot of really cool stuff with AI. So yeah.
Okay. Okay, I have another question. In sports like football, which is now a data-centric sport, do you think AI will fully replace coaches?
No, I don't think so. I generally don't think coaches are going to be replaced in out of their jobs. And again, going back to that same example, because the sport is played by humans, you still need humans to interact with other humans, unfortunately or fortunately. It depends on the way you see it. And like I said, the best approach, and this is exactly an example from chess, is I'm not sure of the exact model, but there was an AI model that was developed to help beat the world's best chess players, and it did it really well. But what worked even better was a hybrid approach. It was AI with the best in the world. So what AI was very good at was strategy and statistics, but humans were very good at understanding the wider context, the higher level strategy, the bigger picture. So I think it's always going to be a combination of using AI when it's needed. Going back to my point, it's just a tool that we use. We can dial it up and dial it down, but I don't think it'll ever replace what we do and how we use it.
Okay. Someone is also asking something similar. Do you think AI is going to have an impact on how we play sports in the future?
Yeah, I think sports always evolve. I think that's a good thing. I think that sports will evolve and change. It makes it more fun when you watch it as a fan, um, entertaining because you don't want to watch the same stuff over and over again. So I think it'll be a good thing. I hope it'll make it more challenging, more competitive, um, and it'll grow. I'm hoping it'll allow more people to hopefully join the sport, take up the sport if it's more accessible. So I think that's always a positive. So yeah, I think AI it'll have its challenges, I'm sure. I'm sure there'll be challenges as we go through it. This AI revolution, as it's called. But I think if we're optimistic, we're positive about it, and we treat it as it is, it's a great new tool, then we'll be all better off for it.
Oh, okay. I have another interesting question. Do you think the best franchise in sports is the one who uses the best data analysis?
No, it's a short answer again. Like I said, it's not always the best. The people who have the most data, those AI resources, aren't always the best at the sport. And again, like I said, it's the combination of the two. When you use it, how you apply it is what's key. A lot of teams around the world where you'd associate, they might have a lot of money, a lot of resource to football, for example. A lot of big teams have a lot of data scientists, but that doesn't necessarily mean they're going to win the next game or win the next World Cup or the Premier League, for example. So and that's again, you could have everything absolutely right, and you can say a 99 predictive power that you're going to win the next game, and you'll still lose because you will never be able to get 100%. At the end of the day, it's still sport. It's humans running around, unpredictability, and that's exciting because you're not trying to predict the value of the stock that's going to go up and down. You're not trying to predict sales in a business, for example. It's sport. It's a very different game altogether, which is fascinating and which is cool. So I think it's never going to be AI is going to be replacing that. Yeah.
Okay, I just wanted to ask, have you been able to remember one of the weirdest data requests you've ever gotten?
Yeah, yeah.
Anything come to mind?
Strangest one. I think we've had some really interesting ones around player. I guess, yeah. Not sure. I'm also thinking, what am I allowed to share? Because obviously, we have to maintain a little bit of competitive advantage, and I have to maintain some anonymity. And the way if I share it might you can deduce who I'm talking about, if that makes sense. So unfortunately, I can't. I don't think I have one that's good enough to share. So I think I'll have to skip that question. Sorry.
Okay.
But
All right.
yeah, it's a
I
very good
have
question. So
some more
apologize for
questions.
that. But yeah.
No problem. It's great. Okay. How much does computer vision and GPS currently impact player training activities on a match-by-match basis?
Oh, I think that's huge. The ability of us that we are now able to capture GPS data for each player and computer vision, like I said, Hawkeye through the tennis use Hawkeye. We use Hawkeye, which is just a ball tracking technology that uses computer vision, is been a game changer in the last decade or so. In terms of getting true insight into what a player, the inputs that go into a player, so the workload, and the outputs, so what the ball is doing. Whereas if you can imagine a tennis player hitting a ball, where it's gone, the top spin, they deliver the bounce, the angles, the energy they exert in combination of those two, understanding that has been a step change in sports analytics. Also from other disciplines within sports. So if you're a strength and conditioning coach or a nutritionist, physio, you have now access to all that information. Football players, they know exactly how fast they've run, how much they've run in a whole match. So you know if they've gone over their workload, if they're about to break themselves, you can pull them back, say, look, so those things have made a massive a step change in sport in the last 10 years to allow us to get deeper insight into injury prevention, planning, workload, and so forth, and also then tactics and then matchups. So if we know this player is better suited against this opposition player, we can plan and be better. And so that's been another change in our sport.
Okay, so I have the last two questions for today. The first one says, does your job require much programming, or is it mostly just data manipulation?
So it does require a bit of programming. I use Python for my programming, and I use that to help with data cleaning and merging and manipulating, applying models, building models. So there is a fair bit of programming experience that are skills that I use throughout my role. I use SQL, and Python is one of my two main sources of programming.
Okay, and the last question, who is your favorite player or coach to work with in the ECB? Do you
Oh,
have
that's a
any
loaded question.
favorite?
It's a loaded question. If any of them see this, I might actually have to go looking for a new job. No, it's a good question, because I think favorite obviously means the ones that are more open to our ways of working, data science and stuff, but also it it's a great experience being involved with so many different personalities in cricket across, and also even in other sports that I've worked for, that they're on different journeys, learning about AI, learning about data, and it's really cool to bring them along that journey, helping them understand the value of some of these tools, so that we can help answer their questions better, faster as well. And that's been the key, is saying that, hey, if you have a question, we can answer it very quickly because we've got AI is changing it. And that's been a really big change. And in their mindset, a lot of the coaches, players, and I guess not just cricket, but across other sports as well. Because sport is fast, it's high performance environments, and that's been really cool. And that's why I like to work with a lot of coaches who are more open-minded, even though they sometimes may not be receptive of your ideas, but it challenges you to think more. If they are more challenging around your ideas and so you may not like them on a personal level, but at least they make you very good at your job. You can be more critical about what you present back to them. So I think it's a really good, cool experience to be in, because we're all learning as AI is growing in this space. Sports and in all other industries is growing, and we all try to understand what it means for us, how we can use it to our advantage, and how, obviously from sport, how we can use it to our competitive advantage, rather than our opponents who are around the world. So that's been the big change for us as well.
Oh, that's amazing. Thank you so much, Farhan, for your time today, for your energy, and for staying with us all through the event. We're so grateful. Thank you so much.
Thank you so much.
And to everyone that's asked us questions, we really appreciate your participation and engagement on today's session. We really want to thank you all for joining this incredible session. And we've really had so much fun, and we learned a lot. And we know that our enthusiasm will help us. And we've seen how sports and AI are changing the games for good. And I'm very sure that you're leaving with new ideas, with insights and motivation to dive deeper into the world of AI and innovation. Just before we wrap up for today's event, I'd like to share some amazing opportunities happening right here with us at Teens in AI. As a special thank you for being here today, you can enjoy a 20% off the courses on our website by using the code Teens in Action June to check that out. We also have new courses for you to learn about computer vision and image recognition, and we also have another one on biocomputing. We also want you to also get unlimited access to our courses and earn certificates via our All Access membership. And don't forget to join our AI for Good summer program. It's an amazing time, 5 days virtual bootcamp, and we hope to see each and every one of you there. Once again, it's our mission to empower the next generation of responsible AI leaders and innovators. And we need your passion, we need your creativity to make this vision a reality. We thank you again for your energy. We thank you for your participation, and we look forward to seeing you at our other events, our workshops, and our Global Teens in Action community. Until then, stay inspired, stay innovative, and have an amazing day. Thank you so much, everyone. Goodbye.